Hello students, and welcome to this session on 6D surface area of prisms and cylinders. So in this lesson I'm just going to go through defining what a prism and a cylinder are. I'm going to talk about total surface area and what that means. We'll have a look at finding the surface area of various prisms, surface area of a cylinder, and also look at some composite shapes as well. So some cylinders on top of cylinders and so on. So just quickly before we go, move on, a prism is a polyhedron with uniform cross-section. So what is a uniform cross-section? Well, I'll give you an example. If I was to draw a cylinder, that's supposed to be a circle, by the way. If I have a cylinder, you can see there that a cylinder has two circular faces. And as you can see, that those two circular faces, those are equal. So that is what we call the cross-sectional area. Now you're probably sort of wondering, well, how do I know what the cross-sectional area is? Because a lot of these prisms have various shapes. Well, what you want to do is you want to be able to, if I was to cut this into even slices, which way would I cut it? Well, basically, I have to cut it this way. Okay, so for example, so that means that this area here, this circle, is the cross-sectional area of the cylinder. Okay, so if I was to try and cut it down into these pieces, they're not going to be even slices, are they? So it's always, so the cross-sectional area is, well, let's have a look at this example. Can you see here, if I was to cut it down this way, that wouldn't make sense. That's not a consistent cross-sectional area. However, it's consistent if I use this triangular area. So these prisms are actually called, this one's called a right triangular prism because it's got a right angle triangle in this case as its cross-sectional area. Which way would we have to cut it? Well, we'd have to cut it going down this way. Okay, so what it has is it has two consistent cross-sectional area. And then, of course, in this case, you'd have rectangles. We're going to get into the other side of a cylinder, which is the curved surface in a moment. So it says here the remaining sides are parallelograms. Well, you know, a rectangle over here is a parallelogram. A rectangle over here is, when we're looking at the curved surface, is also a parallelogram. And so a cylinder has a circular cross-section, whereas, of course, and it's a type of a prism. It's a circular prism. All right, so just getting our head around some of these words. Now, what I'm going to do today is, first of all, well, let's talk about, so hopefully in a moment I'm going to be going through your notes, and if you've got your notes there with you, you can annotate these as you go. Pause the video when you see fit, and I'll get you to have a go at some questions as well. All right, so total surface area, well, we've looked at that in the most recent exercise, but what I've got here is actually what we call a net. So if I was to get a cylinder and I was to stretch out that flat into two dimensions, what it looks like is we've got two circles, and in actual fact, if you think about it, if I had a poster and if I rolled that poster up, that I could make a cylinder, a hollow cylinder, but what it is that curved surface, this curved surface around here, can actually be represented by a rectangle. And that rectangle, well, we're going to give that a height of h. I think that's, you'd probably be okay with that. But where does this 2 pi r come from, you're probably asking? Well, we've just recently had a look at with length, is the circumference of a circle is 2 pi r. It's also pi d, which because there's 2 radius in a diameter. Okay, so either one of those. Often you're using the radius with these cylinder questions, but just be careful if you have to use if you have the diameter, you'll have to halve it and to use the radius. Okay, so just be careful. We're using the radius when we come here. So what we've got is, if you think about it, if we break this up, we've got 2 circles. So the total surface area is 2 circles. And then we've got 1 rectangle. So the two circles we've got, so 2 pi r squared. Now be careful because sometimes we might have just one side of a cylinder. So this is only if we're looking at the total surface area. If I, for example, wanted to paint all the outside, I'd have to paint the outside of that. I'd have to paint the bottom, wouldn't I? And I'd also have to paint the curved surface. But you don't always, you know, it'd be nice if you could just plug the numbers into formulas all the time, but you don't always have that option. Sometimes you'll have to think it through. And if I was to have, for example, you know, a circular cylinder sitting on a rectangular sort of face, then maybe I wouldn't count that bottom one there, because we wouldn't. If I was painting this, I wouldn't have to paint this this circular section here. So you might have to take it away. All right, getting back to it then. So the total surface area is 2 circles. This is 2 circles of a full cylinder, plus we've got 2 pi r, which is the circumference of a circle. It's basically just the area of this rectangle. Its length, which is 2 pi r, which is the circumference of this circle. That distance around here is 2 pi r. And then we're going to multiply that by the height. So this is what we call the curved surface here. This is the curved surface. All right, so if I just asked you for the curved surface area, then I'd just be asking for 2 pi h. I'd just be asking for this thing here. All right, now, later on we'll look at composite solids though. Just be careful, because if you go ahead and find a surface area, I've got 1, 2. You notice in here we've actually got 4 rectangles which all have the same dimension. We have a consistent cross-section, or we can sort of say that we've also got the base there, and we've also got another, so we've got 6 sides. But you notice if I was to count that top side, then I've actually counted, there's no point adding 2 circles, because I'd basically have to take 1 circle away. Take 1 circle away. If I was trying to paint that, you wouldn't need to paint this surface here, would you? Okay, you'd have to take that away. And if I was working out this area here, I've already counted this rectangular area, which includes that circle, so I'd also have to take that away again. All right, so this is some things we need to think about when we're doing those questions. All right. In these, so what we're going to do is I'll go through your notes now. So can I get you, if you've got your notes in front of you, please have them out. And we're at page 9. Okay, so I'm going to go through surface areas of cylinders, and I'm also going to be looking at some composite solids. All right, so now this other stuff later, we're going to go through this in another video, which is looking at surface areas of cones and pyramids, but I'm just going through this today. So in your notes, if you ever need to refer back to it, you can refer back to the formula, but just think about it as 2 circles, and the 2 pi r h is going to be the curved surface. Hopefully you can recall that formula instead of having to look back on it all the time. All right, so let's go through these examples here. Find the total surface area of this rectangular prism and this cylinder. All right, so first of all, when we're setting these out, try to set it out in as few lines as possible, but without skipping any clear steps. So the total surface area is equal to, well, first of all, you can see here that we've got 2 pairs of those sides. Okay, so we've got 2 pairs of those sides, and therefore those sides would have 2 rectangles, length and width of 8 and 5. All right, so I've covered those. Then we've got 2 more. We've got 6 sides to this rectangular prism. So we've got 3 pairs of 2 sides. So there you go. There's another one. And that area is going to be 5 times 3, isn't it? But there's 2 of them. And finally, what we've got is we've covered off those 2 sides. We've also got to cover the other one, which is, there's 2 of those, and that is 8 times 3. All right, so we've got to cover those 2 side lengths here, 1 and 2 at the back there. So that's going to be 8 times 3. All right, so let's do this we shouldn't need to calculate this. 8 times 5 is 40. 40 times 2 is 80. 15 times 2 is 30, and 24 times 2 is 48. Bringing that together, that is 158. Be careful though, it's asking us for total surface area, so we don't want it in centimetres, it's centimetres squared. That's really all you need to do for these sort of rectangular prism ones. Don't need to. So what I see a lot of students do is they break it up. We really want, your mathematics to flow, and that's, please, if you can try to do your working like that. In those steps, but without skipping anything clear. All right, so now what we've got is we've got a cylinder. So the total surface area of a cylinder, especially when you haven't used this very often, let's write out the formula. 2 pi r squared plus 2 pi r h. We could factorise this if you like, or it can be factorised, taking out a common factor of 2 pi, and they both share an r. You can technically, this is just another way of that's another way of doing it, but that's all. I'll forget about doing that way, okay? But you may see some see that somewhere as well. Okay, so what we've got is, first of all, are we looking? So what we want is if I was to paint this, I'd have to paint 1 circle, 2 circles, and then finally I'd have to paint that curved surface, wouldn't I? Okay, so that's what we're trying to find. We're trying to find that total area around that surface. Okay, so we've got 2 circles, so 2, be careful if we got the diameter or the radius. It's lucky, this is the radius, so 2 pi times 1.7 squared. Plus 2 pi times the radius, which is 1.7 times my height. Okay, now I'll have to do this in the calculator as well. It's asking us to do to 2 decimal places when necessary. So, of course, that's going to be an estimate now, so I need to do this one. Put that in the calculator, and you get 74.77 meters squared. All right, so hopefully you can feel comfortable when it comes to doing these in a formula, but when you've got something like this, a composite shape, it's a little bit different because, of course, we need to. If I was to work out this area, well, I wouldn't need to. If I was painting this, I'd be painting everywhere else. I certainly wouldn't need to paint there. So you could do quite a few things, do it a few different ways. But what I think we do is, first of all, the total surface area. What I'm going to do is I'm going to do it in one line if I can. All right, try to do this if you can. Well, first of all, we've got here this bottom side, and there's obviously 2 pairs of those. But remember, so what I'm going to do is I'm actually going to count this rectangular face, but that means I've actually counted a circle where I shouldn't, but we'll subtract that later. Okay, so I've got 2 times, we've got 20 times, it actually says here that that's 20 and that's 20. Okay, so that's 20 times 20. All right, so we've got 2 of those, and as you notice as well, we've actually got, in this case, we've got 4 sides. We've got 20 because the base is a square. Okay, then what we can do is we can say, well, there's 1, 2, 3. There's 4 rectangles of the same area. So there's not always going to be 4 like there wasn't before, and they're going to have a length and a width of 20 times 10. All right, so I've covered 6 sides. But what haven't I covered? I haven't covered the cylinder. But this time, instead of doing 2 pi r squared, we just want to cover this face and the curved surface. All right, so what that is, it's not 2 pi r squared, it's just pi r squared, and the curved surface from before is 2 pi RH. We want to do that 2 pi RH, if you like. And what we need to do, though, is, so that's going to be the total surface area. But if I do that, then what I've actually done is, when I've made this calculation here, I've actually I've done a whole rectangle. I'm going to rub that out. we actually want most of the rectangle. We want this, don't we? So we want this area. All right, we want to shade that in, but of course we're going to do that, aren't we? So what we're going to do is we've actually counted another circle, so I need to subtract pi r squared away from that. All right, so if you can do it in one line, then break it down. That would be great. Okay, if you want to do it in 2 steps, that's okay. Let's work out what this is for the time being. With 20 times 20 is 400 plus 2 is times 2, sorry, is 800. We can work that out. And 20 times 10 is 200 plus, so that's also 800. And pi r squared, let's work this out. We're going to need to do a calculator, or will we? We can try doing an exact first, but we want to 1 decimal place. My advice, though, is what a lot of students do is they work it out in the calculator and they get stuck with decimals and stuff early. Let's try and work it out in exact and then answer the question. So pi times the radius squared, which is 6 squared, plus 2 pi times the radius, which is 6, times the height, which is 8, and then we've got minus pi times 6 squared. All right. Now, as you can see, the good thing about this, if I work this out in decimal and then I had to subtract it away, that doesn't make much sense. So they're actually going to cancel each other out. And what we have is let's bring these together. 800 plus 800 is 1600. And then over here we've got 2 pi. 2 times 8 is 16, times 6 is 96. So that's 1600 plus 96 pi. Well, that's our answer. If I was asking you for exact, you could do this. That would be the exact answer. You just leave it in terms of pi. But what we're going to do is, of course, we've been asked to do to 1 decimal place. So if we're asked to do to 1 decimal place, later on, actually, you'll have a look at last year's test, and we've got sort of a cone and a composite shape, and you should leave it in exact, and we'll do that a little bit later on. Okay, so let's have a look. 1600, if I do that in the calculator, plus 96 pi, that is going to give me approximately equal to 1,901.6. What's our unit? Centimeters, and it's squared for area. All right, now, hopefully that, now obviously at first you're going to be in the habit, you want to break this up, but I'd love you to be able to sort of work out, okay, I've got 2 rectangles of the same dimension, I've got 4 rectangles of the same dimension, and then I've got a circle, and then I've got the curved surface, and then, oh no, I've actually included another circle in here that I wouldn't be painting. I wouldn't need to paint that, so I need to subtract it away. Doing things in exact values, so that way later, look, if there's no way I could work this out, I can do a lot of these things and work these out in my head, but I can't work out what pi is, because pi has an infinite amount of decimal places, 3.14159, so on, so forth. So nobody can work what that out is. You'll need to use your CAS calculator for that. All right, what I get you to do now is have a go at this one. This time I would like you to just pause the video and have a go yourself in your notes or in an exercise book, and I'm going to go through it in a moment. All right, so I'll get you to hit the pause button, give this a go, and I'll go through this really shortly. All right, so hopefully when doing this, hopefully you've given this a go. So first step is I'm going to try and write this out in one equation. What a lot of people do is they write an equation, they write it equal to this, and then they add this at the end. All of a sudden, it just comes out of nowhere. I think that you should really get into the habit of doing that in one go, please, recognizing those shapes and bringing those together. So I've got here that we've got two sides of those. Okay, and then I've got 4 sides of this rectangle, which has dimensions 4 and 2, length and width. And then I've got a circular section. We've just got the 1 this time, and then we've got a curved surface. And of course, when I've worked out the area of this rectangle here, then I need to remember that I need to take away a circle. So we've got that is subtract 1.5 squared times pi, or pi r squared. All right, so as you can see there, by doing that, that means that these are going to cancel out once again. And let's go ahead and work this out. We've got 16 times 2 is 32. 16 times 4. So we've got... So we've got 2 of 4 by 4, which is 32. We've got, and so we've got here 8 times 4 is also 32. And then we've got this 2 pi h, the curved surface there, which is now 2.2 times 1.5 is 3, times 4 is 12. Look at that. We've just worked, no rounding, no decimals. We can do the rounding at the end if we need to. Bring those together, we've got 64 plus 12 pi. That's our answer in exact. Okay, so often you might be asked for the exact answer, but we've been asked to correct to 1 decimal place. So that is approximately 101.7 meters squared. All right, so hopefully you got that, and if you are, then you should feel confident with most of them. But let me just talk about a few other questions you'll encounter in your coursework. So let me just have a look and just talk you through some of those without actually doing them. All right, so some of these other questions you'll need to do in your coursework. We've also got to consider that we might have some sectors of circles as cross-sections. So, so for the most part, you should be able to do you'll be able to hopefully do these ones, which you'll need some practice with. Then you'll have some, these are all rectangle, these are all prisms. We've got here, we've got a rectangular prism over here, okay? But of course, the consistent cross-sectional area, well, you could do it a few ways. You could cut this in a few ways, but I could sort of say that that's a cross-sectional area. But we can also use this as a cross-sectional area as well, because in actual fact, if I was to cut it in this direction here, then, oh, that's not a very good one. If I was to cut it, you can see there that I could cut it this way and everyone would be happy if I was to cut that and give everyone equal slices. So this one is can be done like that. But this one, you can see that the cross-sectional area has to be this triangular face here, because we would have to cut it in this direction here. So how would I work that out? Well, the total surface area, you've got you've got two triangles, each times a half times the base times the height, and then in this case you would have 1, 2, 3 rectangles. Okay, 3 rectangles plus 3 rectangles, so those should be okay. Similarly with those, you'd have to look up your formula for a parallelogram. So we've got triangular faces, trapeziums as well. We've got trapeziums there as well. So you'd have to work out the area of those trapeziums. But finally, when you're doing these ones here, make sure that, this before we'd need to use that as a cross-section. This is a cylinder, but it's a quarter cylinder. Okay, so what we'd have to do is what I would do is I would basically say, okay, well, I've got a cylinder, and the total surface area of a cylinder is 2 pi r squared plus 2 pi r h, but as you can see, there's only a quarter of it. Okay, so that'd be a quarter times 2 pi r squared plus 2 pi r h. And then, of course, that's just going to work out the curved surface plus the 2 circles, but what surface have I missed? Well, in this case, there's actually, because I've cut that, there's actually this rectangle down here, which we haven't actually included. So you've got to think about, have I included all of the shapes? If I wanted to paint at the outside, I'd have to paint that undercarriage there. So we would then have to add 10 times 3, which is 30 to that. Okay, so as you can see, this one here, it's just a cylinder. It's a quarter of a cylinder, and what a lot of you will do is you'll actually work out what the area of a whole cylinder is, and then you'll sort of go, okay, well, I'm going to multiply that by 4. Well, you're going to divide that by 4. But I think that what you should really be aiming to do is set out your working like this. All right. Once again, this is, instead of a quarter cylinder, this one here is a half cylinder. This is a 3/4 cylinder in this case, and this one over here we've got a fraction. Okay, and it's very similar to what we've been doing. All right, so hopefully that is enough. I'm going to stop right there. Can I get you to try those questions, and I will see you in the chat soon.